If you thought the latest images from the James Webb Space Telescope were impressive, what you are about to see could completely change your perspective. A new space telescope has quietly begun sending back images so detailed, so vast, and so revealing that scientists have openly admitted they were not fully prepared for what they were seeing. The Euclid Space Telescope has released its first light images, and they do far more than showcase beautiful galaxies. They reveal structures we barely understand, patterns shaped by invisible forces, and a universe that appears far more complex than anyone expected. Today, we are going to explore what Euclid has captured, why astronomers are calling these images revolutionary, and why some of them become truly astonishing once you understand what you are looking at. Stay with me until the end, because these first images are only the beginning of what Euclid is expected to reveal over the coming years. Euclid is not an ordinary space telescope. It was never designed to focus on a single nebula or zoom in on one spectacular galaxy. Instead, its mission is far more ambitious. Launched by the European Space Agency in July 2023 and positioned approximately 1.5 million kilometers from Earth at the Sun-Earth Lagrange Point 2, L2, Euclid was built to map the universe on a scale never attempted before. Its ultra-wide field of view allows it to capture enormous regions of the sky in a single observation, while maintaining extraordinary resolution. This enables Euclid to image individual galaxies in remarkable detail, while simultaneously revealing how millions of them are connected across immense cosmic structures. More importantly, Euclid is not simply mapping visible light. It is tracing the influence of dark matter by measuring the subtle distortions in galaxy shapes caused by gravitational lensing. In effect, Euclid is helping astronomers reveal the invisible framework upon which the universe appears to be built. When Euclid transmitted its first mosaic of the southern sky, scientists were astonished by its scale. During a relatively short observing period, the telescope captured 260 separate images, covering an area of sky roughly 500 times larger than the apparent size of the full moon. When combined into a single mosaic, these images revealed millions of stars and galaxies. Even more remarkable is that this enormous dataset represents only about 1% of the complete sky survey Euclid is expected to produce during its mission. What we are seeing today is not the finished map, but only a tiny fragment of something unimaginably larger. Researchers can smoothly zoom from the largest known cosmic structures down to individual galaxies without losing clarity, allowing them to study how matter is organized across billions of light-years. This enormous mosaic is much more than a beautiful photograph. It is the first glimpse of what is expected to become the most detailed three-dimensional map of the universe ever created. At the same time, it reminds us just how little of the cosmos humanity has truly explored. One of the most remarkable discoveries from Euclid's first observations comes from the Perseus cluster, located about 240 million light-years from Earth. A single image contains more than 1,000 known galaxies along with over 100,000 distant background galaxies. Yet the greatest surprise came when astronomers examined the data more closely. Euclid identified more than 630 previously unknown dwarf galaxies hidden within the cluster, objects so faint they had escaped detection until now. This discovery is especially important because dwarf galaxies are highly sensitive to the gravitational effects of dark matter. Their positions, shapes, and distortions provide valuable clues about where dark matter is concentrated. The fact that so many of these galaxies remained invisible until Euclid observed them suggests that the distribution of dark matter may be even more intricate than previously believed. Rather than simply existing alongside ordinary matter, dark matter appears to provide the invisible framework around which galaxies are assembled. Euclid's discoveries are not limited to enormous cosmic structures. They are also transforming our understanding of individual galaxies and stellar systems. In galaxies such as NGC 6822, the telescope has revealed low-metallicity stars that closely resemble conditions found in the early universe, providing astronomers with important clues about how galaxies evolved billions of years ago. In globular clusters such as NGC 6397, Euclid resolved faint stars along the outer regions that had previously been hidden by the overwhelming brightness of neighboring stars. These observations are helping scientists reconstruct the formation history of the Milky Way with greater precision than ever before. Meanwhile, in regions such as the Horsehead Nebula, Euclid's extraordinary sensitivity uncovered evidence of free-floating planetary mass objects drifting through space without orbiting a parent star. These observations suggest that rogue planets may be significantly more common than previously thought. Together, these discoveries paint a picture of a universe that is not calm or static, but dynamic, crowded, and constantly reshaped by both visible matter and invisible gravitational forces. As scientists assembled more of Euclid's observations, another striking pattern became impossible to ignore. Galaxies are not distributed randomly throughout space. Instead, they are arranged along enormous cosmic filaments, vast threads stretching across hundreds of millions of light-years and intersecting at dense regions where massive galaxy clusters form. Euclid's images reveal this structure with extraordinary clarity. Rather than resembling isolated islands scattered through empty space, galaxies appear woven together into an immense cosmic web, with matter flowing along invisible pathways largely shaped by dark matter. These filaments are no longer merely theoretical predictions. Their influence can be observed directly through the way galaxies bend, stretch, and align under gravity. Perhaps the most astonishing aspect is the scale of this cosmic web. It dominates the large-scale structure of the universe, with every galaxy, every cluster, and every enormous cosmic void existing within its framework. Ordinary matter follows pathways determined by forces that remain invisible to our eyes and are still only partially understood by modern physics.